question 3 asks you to find the sum of the first 5 terms of this sequence. It is a recursively defined sequence. The first 2 terms are given, and then it says for n greater than or equal to 3. So in other words, starting with the third term, I'm going to apply this rule. So I'm going to just start listing my terms here. A sub 1 is equal to 2. A sub 2 is equal to negative 3. So I only have to find 3 more terms. I already know the first 2. A sub 3, okay, so every place there's an n, now I'm going to put a 3. So 3 minus 1 is 2. So this would be A sub 2. 3 minus 2 is 1, so this would be A sub 1 plus 2. Well, it says multiply A sub 2 times A sub 1 and add 2. Well, A sub 2 is negative 3. Oops. A sub 2 is negative 3. A sub 1 is 2. So the A sub 3 is equal to negative 3 times 2 plus 2, which is negative 4. Then I do the same thing for A sub 4. A sub 4 then, plugging a 4 into the formula, would be A sub 3 times A sub 2 plus 2. Well, A sub 3 is negative 4. A sub 2 is negative 3, and then add 2. Negative 4 times negative 3 is 12, plus 2 is 14. So the second term is 14. Then A sub 5 would be A sub 4 times A sub 3. So that would be 14 times negative 4, which is negative 56, plus 2, negative 54. So I keep hitting the eraser button when I mean to push red. Okay. There we go. I have 5 terms. Add them up. The sum is negative 45. And that's the answer. You're probably thinking, that was a lot easier than I thought it was. Exactly. If you understand what the problem is asking, they're not hard. So remember how to apply a rule. Now, I will say a lot of you tried to use a sum formula from the back page to add this up. Mostly you tried the arithmetic sum. This is not arithmetic. We're not adding the same amount each time to get from 2 to negative 3 to negative 4 to 14 to negative 54. Nor is there any kind of a multiplication pattern. It is not arithmetic. It is not geometric. No formula applies to this. Just add them up. So realize that a sum does not have to use a sum formula. Okay, so let's look at this last question, which was an explanation question. There was a little glitch in what I wrote down. I meant to write down the formula for a geometric term, okay, just like that, without the negative who, but with the A sub 1 in here. N is the term number, okay, so if I want to find term number 100, for example, I would make N 100. So it's the number of the term. It's the position in the sequence. A sub n is the term in position n. So it's an actual term of the sequence. So if I say A sub 100 equals 5, that means if I go 100 times, if I go to the 100th spot in the sequence, the number in the sequence is 5, but the term number is 100. R has a special name. It's called the common ratio, but that's not really what I wanted you to say so much. What do we do with this R? It's the number we multiply by to get to the next term. It's the number we multiply, oops, left the word out, multiply by to get the next term. So every time we want to get to the next term, we multiply by R. Or it is the common ratio between terms, you could say that also. In other words, A sub 2 divided by A sub 1, A sub 3. So I'm going to write that down. A sub 2 divided by A sub 1, or A sub 3 divided by A sub 2. All of those would equal R. Now the last part, a lot of people had trouble understanding what exactly I was looking for. It's to find the nth term, or the term in the nth position, in a geometric sequence. I wanted you to recognize that this formula applied to a geometric sequence when we have a multiplication pattern. To find the nth term in a geometric sequence, start with the first term. Okay, that's A sub 1. and multiply by r n minus 1 times. Okay, so let me just give an example. Let's say I want to define a sub 6 and a sub 1. So what I would do to find a sub 6, I would take whatever a sub 1 is times r times r times r times r times r 5 times. Okay, so to get to the 6th term, I would multiply by r 5 times. I wanted you to understand what that formula is telling you. If you understand the formulas, it'll make this whole unit so much better. So that's what I was trying to get you to do, is explain to me what this formula is telling you.